Third part of this classwork has us doing a number of integrals. When I look at the first one, I want to take it step by step, doing 12 and 2x separately. When I look at 12, since it's just a constant, when I integrate it, it's going to be that same constant with an x added in. When I look at 2x, that's going to become 2. It used to be x to the first power. I'm going to add 1 to that, so it now becomes x to the second. I'm going to divide by the new power. Always plus c. Just cleaning that up a little, the 12x can stay. These 2's cancel and just leave me with x squared, still plus c. Second problem's a little trickier, only because we have a fractional exponent here. So when I find the new power on x, I'm taking what used to be 5/2, adding 1 to it. Really that means adding 2 over 2. If I take 5 over 2 and add 2 over 2, I end up with 7 over 2. Always divide by the new power. When I do the same thing with 3x squared, 3x used to be to the second power. If I add 1 to that, becomes x to the third. Divide by the new power. Finally, a -1. All I do if it's a constant is plug an x in with it. So it really would be -1x, which I can call -x. I then have to do plus c. If I clean this up a little, this is a fraction on bottom. To divide by a fraction, I flip it and multiply. So it becomes 2 on top, 7 on bottom. X to the 7/2 really means 7th power under the second root. So I'm going to put it under the root, x to the 7th. These two 3's can cancel, just leaving me with x to the third. This -x stays, this plus c stays. So this would be my final answer to the problem. For part C, before I can begin, I'm going to need to translate it to powers and roots. So this is really the same thing as the integral of x to the 8th power over the 7th root dx. When I integrate, again, I'm adding 1, but 1 means fractionally this denominator over itself. So when I add 1 to the power, I'm not really adding 1/7, I'm adding 7/7. 7/7 plus 8/7 gives me a total of 15/7. So it becomes x to the 15/7 divided by 15/7 plus c. Cleaning it up a little, flip and multiply. 7 over 15. This is x to the 15th power under the 7th root. X to the 15th power under the 7th root. And then we always need that plus c constant of integration. Again, for d, because it starts out as 1 over x to the 5th dx, we're going to need to move it into a single exponent before we can integrate. So this is going to become the integral of x to the -5 dx. If I follow my integration rules, I add 1 to -5, that gets me to -4. I divide by the new exponent, also -4, and then I add c. Cleaning it up a little, this x to the -4 can come to the bottom as x to the +4, so it becomes 1 over -4x to the 4th, still plus c. This last problem involves sines and cosines, which we haven't dealt with yet. Really, it's just the reverse of what we know about sines and cosines. So since we know that the derivative of sine x equals cosine x, that means we also know that the integral of cosine x equals sine x. On the other side of things, since the derivative of cosine x equals negative sine x, we know that the integral of negative sine x equals positive cosine x. And really when we do these integrals, I should be saying plus c. But the key distinction here is if we start out with a sine, if it's negative sine, it becomes positive cosine. If it's positive sine, it becomes negative cosine. If we start out with a cosine, that becomes just positive sine. So, when we're integrating here, this first 3 stays with the first term. It was a cosine x. When we integrate a cosine x, we get sine x. My second term is negative 5 sine x. That 5 stays with this term, but since when I integrate a negative sign, I get to a positive cosine, that negative sign flips to a plus. Last thing I need is my constant of integration, plus c.